Human impact. Human actions can have both a negative or positive impact on the environment. A. The primary reason humans have a negative impact on the environment is because the human population is growing, which places a greater demand on resources such as food, water, and space. B. There are no easy solutions to any ecological problem. Every solution can have negative consequences. Choosing the right actions requires weighing the benefits with the risks. C. Human actions that generally have a negative impact on the environment include 1. Development, industrialization. 2. Pollution of air, water, and land. 3. Farming. 4. Overhunting, overgrazing. 5. Clear cutting, deforestation. 6. Introduction of foreign species. D. Actions taken by humans to reduce or repair damage to the environment include 1. Recycling wastes. 2. Conserving available resources. 3. Using cleaner resources, for example, solar or wind energy over fossil fuels. 4. Protection of habitats and endangered species. 6. Use of biological controls instead of pesticides. 6. Farming native plants, for example, cocoa in the rainforest. 7. Planting trees to replace those cut down. 8. Rotating crops or planting cover crops to reduce soil loss. 9. Passing laws to control pollution, land management, hunting, and fishing. Specific environmental problems. E. Industrialization. 1. Cause. Development of factories and cities. 2. Negative effect. Increases use of resources, increases human population, increases pollution, acid rain, global warming, and habitat loss. 3. What can be done? Plan carefully. Use cleaner technology. Pass laws to regulate development. F. Acid rain. 1. Cause. Burning fossil fuels, releasing sulfur and nitrogen in the air, which react with rainwater to form acid. 2. Negative effect. Acidification of lakes and soil, damages wildlife and plants, increases erosion of buildings. 3. What can be done? Use filters on smokestacks from factories. Use buffers to neutralize acids in lakes and rivers. Reduce use of fossil fuels. G. Depletion of ozone layer, not related to global warming. 1. Cause. Use of CFCs, chlorofluorocarbons in aerosol sprays and refrigeration coolants. 2. Negative effect. Allows more UV radiation into atmosphere. Increases skin cancer rates. 3. What can be done? Don't use CFCs. Use safer chemicals. H. Loss of habitat. Example, deforestation. 1. Cause. Industrialization, farming, increasing human population. 2. Negative effect. Loss of biodiversity. 3. What can be done? Pass laws to protect natural areas, such as national parks, wildlife sanctuaries, control population growth. I. Loss of biodiversity. 1. Cause. Habitat loss, overhunting, fishing, harvesting. Pollution, introduced species. 2. Negative effect. Ecosystems are less stable. Humans lose potential resources. 3. What can be done? Pass laws to protect species. Regulate hunting. J. Global warming. 1. Cause. Increased emissions of greenhouse gases from fossil fuels, especially CO2. 2. Negative effect. Climate change can lead to loss of habitat and species. 3. What can be done? Cleaner technologies, alternative energy, reduce CO2 emissions. K. Introduced species, also known as invasive or alien species. 1. Cause. Humans moving around the planet, tourism, business, etc. 2. Negative effect. New species may outcompete native wildlife. 3. What can be done? Control importation of new species, use biological controls, natural predators and disease to control population. Common mistakes. False. Energy is recycled in ecosystems. True. Energy can never be recycled. Carbon, water, and nitrogen are elements that are recycled. False. Decomposers are autotrophs because they grow in the soil. True. Decomposers are a type of heterotroph. They obtain food by decaying dead organisms. Lab skills. 1. Terms. A. Observation. What is seen or measured. B. Inference. A conclusion based on observation or evidence. C. Hypothesis. A prediction based on available evidence. A good hypothesis states both cause and effect. 1. A correct hypothesis can be tested and falsified, proven incorrect, using an experiment. 2. The easiest way to write a correct hypothesis is as an if-then statement. Example, if I give patients this pill, then they will not get sick. D. Theory. An explanation of natural events that is supported by strong evidence. 1. Theories tie together many scientific facts, hypotheses, and laws. 2. Common mistake. False. Theories are things that are opinions and are not proven. This is an incorrect use of the word theory in a scientific context. A scientific theory is not a simple guess or conjecture and is strongly supported by evidence. 2. Controlled experiments. Compares the results of an experiment between one or more experimental group with a normal group. A. Experimental group. Group being tested or receiving a special treatment. B. Control group. Normal group. Should be identical to experimental group in every way except one. It does not receive the new treatment. C. Placebo. A sugar pill or other fake treatment given to the control group, usually only needed when using human subjects. D. Independent variable. Variable that is being tested, for example, a new drug or new fertilizer. 1. The if part of an if-then hypothesis. This is the treatment. 2. The independent variable is always plotted on the x-axis. E. Dependent variable. Variable that is measured at the end of an experiment. The results. 1. The then part of an if-then hypothesis. 2. The dependent variable is always plotted on the y-axis. 3. Data tables and graphs. A. Data tables are used to organize data which will be plotted in a graph. 1. First column in the table is for the independent variable. 2. Second column is another for a dependent variable. 3. Each column should be titled and include units of measurement. 4. Data, independent variable, must be arranged in either ascending or descending order. So from small to big or big to small. B. Both the x and y axis of the graph must be labeled. These labels are typically the same ones used in the data table. Once again, units of measurement must be written with the label. 1. The independent variable is always plotted on the x-axis. 2. The dependent variable is always plotted on the y-axis. C. The x and y axis must be numbered. 1. These numbers must increase by uniform spacing. That is, you must count by 2s or 5s, etc. 2. Your numerical scales should take up most of the axes. Squeezing it all into the bottom corner makes the graph impossible to read and no credit may be given. 3. Graphs are often line graphs, but bar graphs may be used. Check test directions carefully. 4. Do not use arrows. Do not use break symbols.